Hi everyone, I'm Yozo Yugen. In this video, I'd like to show you high-speed impact analysis using free software. First, I talk about the contents of the analysis. This analysis is shown in the website of Abacus documentation. The title is Eroding Projectile Impacting Eroding Plate. This example simulates the oblique impact of a cylindrical projectile onto a flat armor plate at the velocity of 2000 m/sec. For more detail, please check the web page. Then, let's consider how to do without Abacus or other paid software. We need to prepare at least 3 tools. The first one is for pre-processing, modeling and meshing. The second one is solver. The third one is for post-processing. In modeling and meshing, I use some tools for simple meshing programs. In this analysis, we need 2 mesh models for the projectile part and the armor plate part. For the projectile part, we need mesh of cylindrical shape. So I use the program Abacus Cylinder Imp.m, which is simple meshing code written in MATLAB language. We can get it from GitHub. Using this program, we can get the data of nodes and elements by only inputting the size and the number of element division of the cylindrical shape. In the same way, using Abacus Plate Imp.m, we can get the data of nodes, elements, and the set of nodes for fixed boundary conditions for the armor plate. So now we got the nodes and the element data. We can make Abacus imp file manually by adding other analysis informations like material properties, initial velocity conditions, boundary conditions, step size, and more. Next, for solver, I use HAKAI, which is simple FM dynamic explicit solver. HAKAI is open source program and we can download it from GitHub. Finally, for post-processing, I use ParaView because HAKAI output the results in VTK format and it can be shown in ParaView easily. Then, let's try the analysis. At first, I'd like to test by small model, rough meshing model. Using mesh tools explained earlier, I got the model as shown in this image. I use full-scale model, not half-symmetric model, because the half-symmetric model is not available for HAKAI solver now. I set the material properties and analysis steps as shown here. Then I executed the analysis. I show you the result of the test analysis. This is the animation of deformed shape. And these images show the deformed shapes at each analysis time. The upper images show the result of Abacus, which are given by Abacus document webpage. The lower images show the result of HAKAI solver. If I roughly evaluate, I think it shows almost good coincidence. So, let's try the huge model with fine mesh. By inputting large number for element divisions to mesh tools, I got the fine mesh model shown in this image. Actually, the mesh size of Abacus example is smaller than this model, but by the reason of my PC's spec, this is the maximum model size for this time. Then I executed the analysis. I show you results. This is the animation of deformed shape. Same as the previous slide, these images show the deformed shapes at each analysis time. I think it shows very good coincidence. There are differences for timing in failure of elements, but it is natural. Because in HAKAI solver, some simplified expressions are used for contacting algorithm, material properties, and others. Now that's all. If you're interested in the solver and tools which I used in this video, please check GitHub URLs listed in the description of this video. Thanks for watching. Bye for now.